Okay. Hi, everybody. Can you hear me okay like this? Okay, sweet. So, hi, welcome, good morning. So today, like Mandy said, we're going to talk a little bit about the architecture that underlies Chorus. And want to just spend a few minutes talking about just like generally like how we think about system architecture, how we make changes to it, how we make plans to make changes to it, how we understand whether our system architecture is aligned well with our kind of product vision and goals, our business goals. And then instead of kind of like giving all huge comprehensive overview of all things that are underneath the Chorus hood, I thought I would just kind of focus on three big architecture initiatives that are underway right now that maybe some of you have heard about, but you don't really know what's the deal with Content API, what is GraphQL. And so I want to kind of demystify some of those things, go into a bit of depth in them, and hopefully just, as Mandy said, give everybody kind of a mental model of how things are structured under the hood and like kind of where we're headed. So we're going to talk about Content API, the kind of subsystem that's going to be the owner of content and publishing. We're going to talk about GraphQL and Tower. This is like our overall strategy for how we build APIs on this team. And then we're going to talk about kind of like development environments and just kind of how we go about getting reliable end-to-end development and deployment tooling. So we can kind of go from idea to thing, ship to production as little hassle as possible. So that's it. That's what we're going to talk about. So let's dive in here. What is even system architecture? So the simplest way I could think about this is architecture is just the way that we carve up product functionality into applications and components, and then how those things talk to each other, how they interact with each other. Like whenever you think about implementing some product feature, some screen in an application, a developer's going to go and write the code to make that thing happen, and they might add some code to an existing application. They might stand up a new service alongside of it. They're going to make some decision about what data store to use, and all those decisions have like consequences for what we can do with the system. And the architecture is just the sum of all those decisions that all of us engineers are making kind of on a day-by-day basis. And so, how do we do architecture? How do we evaluate whether our architecture is any good? How do we know if architecture is set up the right way to kind of meet the needs of our product, of our business? And I think again, like the simplest way I can think about this is our system architecture is successful if it kind of provides like the right foundation for the kinds of products we need to build. Like if you're a product manager, you go to a developer and say, hey, would you add like a new field to the story editor? If they, if their eyes light up, they're like, yeah, that's like a one-line change. I'll get that out today. That's a sign that maybe architecture is geared well towards the kind of product changes we want to make. If instead it's like just a horrible slog and you have to touch like 3 different code bases and make all these hacks and it takes a long time to get out, then maybe the architecture is not so well set up for the kinds of products that we want to build. And then like the second point here is just kind of speaking to the fact that our plans for what we're going to do with architecture are successful to the extent that they don't describe an ideal foundation for what we need to do today, but what we think we're going to need to do in the future. So like business needs change all the time. We didn't know a year ago that we were going to be necessarily we're going to be a SaaS company. But to the extent that you can, you want to kind of try to see into the future and kind of imagine, see where the business is going, see where the product is going, and try to build for where we're headed as opposed to where we are today. And then to get a little bit more specific, like some of the kind of like the ways that we kind of evaluate system architecture, the kind of some of the characteristics of system architecture is like how performant is the system, how secure is it, how reliable is it, how extensible is it, how maintainable is it, and those things. It's hard to be perfect at all those things at once. Usually there are trade-offs. If you're good at one thing, you're probably less good at another thing. But that's kind of, those are kind of some of the ways that we look at architecture. And I think the things we're going to be talking about today are mainly related to kind of reliability, extensibility, and maintainability. We'll see those details here in a second. And so again, the three things we're going to talk about today: Content API, GraphQL and Tower, reliable dev deployment tools. And I think I'll just dive in here. We can get into the specifics in each section. So let's talk about Content API. What is Content API? So this is kind of like very high level view of how we kind of want things to be, right? Like we have you can kind of think about these three core products, product suites that are at the top of this diagram. We have editorial tools, we have a story editor, we have an asset manager, we have things that our content creators use to make and manage their content. We have our websites, the kind of like audience-facing manifestation of content. And then we have like partner platforms, Apple News, Google AMP, all these places we have to send out our content to where our audience lives. And what we want is for there to be like a really great kind of subsystem that underlies all those products. That's the content API. So this is the thing that like has our content database, has all of our draft and published content. It defines our rich text content schema. So the way that we kind of like structure content under the hood. We don't store content as HTML. It's like in a kind of a more structured JSON format that can be translated into other, into like a myriad different kinds of outputs. You know, our suite story editor like supports simultaneous editing and autosave, and all that stuff requires a lot of complex like back-end logic to make all that work. We want the content API to be responsible for that sort of back-end logic so that the editorial tools don't have to worry about how that happens. They just know that they want to provide a great user experience. Yeah, and then we have like, you know, content versioning. We keep track of all the history of all of our every piece of content, who changed what they changed, when they changed it. And then just generally the general publishing pipeline, like scheduled publishing and everything that goes into making a draft post live. So it's like a bunch of stuff. It's really important. All this stuff has to work really, really well. And we want it all to be kind of like encapsulated inside of a content API subsystem that's just like really great at doing those things that we can build products on top of these products here, and then maybe new products that we haven't imagined yet. So this is where we want to get to. This isn't really the reality today. So I thought that might be helpful to explain like why, what are we even doing here? Why isn't that the reality? Like, what is the current state of things, and why are things like that? So I'm just going to kind of like give a little bit of historical context here. If we go back in time, back prior to 2013, you know, the architecture, of course, was like pretty simple. We have, so we have this blue box here labeled SBN. This is our big old monolithic Rails application. This is the first application we built on this team, like the first lines of code in the platform are written in this. It's been at the kind of core of everything all this time. And it had like kind of two critical functions. One was to provide these editorial tools. That's what our old story editor used to look like, where editors can put content into the system. And then we have our websites where kind of present that content out to folks. Kind of basic CMS stuff. This thing is called SBN because company used to be called SB Nation. The thing wasn't called Course back then. It was just the web application that ran our blogs, and SBN is short for SB Nation. And it's really hard to change repository names after the fact. So it's been that name. It's been called that for 10 years. Sorry. So if we fast forward to 2014, like at this point, we had, you know, over that period of time, we've been doing a lot of things, launching new brands, turning from SB Nation into Vox Media, focusing a lot on kind of the audience experience, and our kind of editorial tools that kind of languished. Where we started off with a really simple, pretty easy to use story editor. Over the years, all kinds of functionality have been glommed onto it. It's pretty bloated from a user experience perspective, from a code perspective. We had some reliability issues. Folks would sometimes lose their work, which felt terrible. And we just kind of knew that, well, you know, courses, you have one job course to be a great tool for editors for content creators to create content. We knew we had to kind of reimagine those tools and really invest in them. And so in 2014, Vox Media acquired a little company called Editorially. Some folks you might know joined the team: Andy Brown, David Yee, Jason Santa Maria. We paired them with some existing Vox Media folks, Blake and later Nosley and Nicole, Scott Kellum, and they kind of came together, and they had the mission of just like reimagine our editorial tools, make a really great story editor. How do we have the best story editor in the business? And it was, we approached it from like a product perspective, where we knew we wanted to be user-centric in the way that we built this thing. We knew we wanted to get something out into production fast and start to get user feedback on it. And we knew that we couldn't, while doing that, we couldn't like disrupt the work that our writers were doing on a day-to-day basis to make the company work. You know, we knew we couldn't just like start like changing up the existing story editor in radical ways, because that thing was depended on by our content creators. And so what we did was we said, okay, well, let's just stand up a new thing alongside it. And this is going to be a beta story editor. People can continue to use the old one, but they can also opt into the beta. They, we can kind of like get something minimal out fast. It doesn't have to be feature complete. It just has to be like good enough for folks to use to do basic things. And then we can kind of, iterate on it from there. And so we launched this new story editor in like 6 weeks. Folks were really happy with, really excited about it, really happy with the process that followed from there to iterate on it and make it better and better in response to user feedback. And then what we did was so we built this new little app called Anthem that powered the story editor. We wanted to make some different technical choices there to support some of the product requirements, like around autosave and continuous editing. We made this a Node app instead of Rails, so we could better support those things. And so we had the freedom to kind of from a product perspective, from a technology perspective, to do what we wanted to do to make a great product. And then what we did was we just kind of when somebody clicked publish in Anthem, we would make an API called SBN to say, hey, here's some content for your database, put this on the websites. So this all made sense. This was pretty straightforward. And then for the next few years, things got more complicated, right? Like the beta editor turned into the editor. It took on more and more responsibility, provided more and more functionality. The old editor turned into the legacy editor. It's still there, still used for some things. But these two systems kind of lived side by side for a long time. And generally, like in software design, one of the main things you want to do is you have like a responsibility for something like publishing and content. You want that to be encapsulated inside of a single service so that you can make changes to it without affecting the rest of the system. And we ended up in this situation here where that's not the case at all. We have this responsibility spread across a couple of different systems, Anthem over here on the left and then SBN on the right. The fact that was the case required a lot of bookkeeping to kind of just keep things in sync. When certain data was stored in certain databases, certain functions were only available in certain apps, and to keep things in sync, a lot of complexity. We had to deal with a lot of complexity. The developers who worked on this had to kind of keep that complexity in their heads. Getting new developers up to speed on this stuff is really hard because there's just a lot to figure out, and a lot of just developer energy that could go into making great products is instead going into just navigating this complex system. And so this is kind of the current state of things. We've kind of begun to, the fact that there's a green box here called Content API, this is our first step towards getting to our ideal state where we kind of said, actually I'll just go to the next slide, just kind of show where we're headed. So this is the future, right? Each of these boxes here, each of these services should have kind of a single responsibility, or how it should have fewer responsibilities. Like the Anthem app, the original Anthem app we built to power the story editor. We want that just to be responsible for providing great UI. The story editor user experience should be really great, and that's its job. For all the kind of complex publishing logic, content storage, all that stuff, it should be able to depend on the Content API to do that. Content API provides a really great API. Anthem can call to for saving and auto saving and scheduling and all that stuff. Anthem doesn't have to know how that stuff works under the hood. Content API is in charge of all that. And then SBN, the old monolithic Rails app, can become simpler. It can, instead of having to worry about publishing and audience presentation, it can just be focused on providing a really great audience experience. The Unison product that hopefully all are aware of is kind of baked into the SBN app. SBN doesn't have to worry about draft content or things are scheduled to publish or not. It just, it'll get a signal from Content API when a new piece of content has been published. SBN will grab a copy of that, and then from there it just shows it on the websites. So this is the kind of the world we're trying to work towards, where visions of responsibilities are very clear, separation of concerns are very clear, and we just have a nice, sane, rational system to navigate. So that's some of the history, and that's kind of where we're headed. And just a couple more notes. This is kind of just summarizes kind of what I just said here. So the goals of Content API: single owner for course content and publishing. Make it so that we can really easily, as a product team, create and iterate on story formats and audience and authoring experiences. Just get to a system that's just easier to reason about and evolve. We have, so the ecosystem team, just to get kind of specific, your ecosystem team has a roadmap to start doing all this stuff this quarter. And I'm really excited about where I think we're going to end up on the other side. I think it's going to be a really great, sensible system. And again, like just free up our developers to be making great products instead of kind of navigating this complexity. That's Content API. So now let's talk about GraphQL and Tower and how we build APIs on this team. So before we went down this GraphQL Tower path, the state of things with respect to our APIs was kind of like this, right? We didn't really have any, as a development team, didn't really have any kind of like thought through API strategy or standards. All these like services that underlie Chorus, and every one of them kind of like did its own thing with respect to the API, like how it provided docs or didn't provide docs at all, like how it handled errors, serialization, all the things that go into an API. Like every API kind of did it its own way. APIs often ended up being incompatible with each other in subtle ways. Like there's no kind of, for example, standard way to sort of like authenticate an API request being made on behalf of a specific user, do permissions checking for that user. Every API kind of did it a little bit differently, which makes it really hard as like you're trying to build a product on top of these APIs to know how to handle that kind of stuff. Data spread across many different APIs, unclear which API to use for what. And then just generally speaking, a lot of bike shedding or kind of just like focusing on like unimportant trivial problems and kind of resolving the same API problems over and over again for every API we build, instead of just like focusing on the stuff that matters, you know, it's kind of making the underlying business logic of your API, making great products. And so when we set out with this GraphQL and Tower work, our goals were to deal with some of these things. Like we wanted to have a consistent way of building APIs and integrating apps with each other. Just make some decisions about how we're going to do it. It's almost less important like what the decisions are than like we just made some decisions and like this is the way we're going to do it. This is the way things are going to work. Avoid bike shedding. Allow our engineers to focus on what matters. Make underlying applications easier to refactor. So if you have a great API kind of abstraction layer, then theoretically under the hood, you can kind of like make changes to the internals of an application without affecting the rest of the ecosystem. But you need a good API layer to do that. And then like we want to kind of prepare to open up APIs beyond our team. And as Mandy was saying before, we didn't necessarily know about the SaaS business when we started with this work, but we kind of knew that we'd had been various like reasons over the years that we considered maybe opening up APIs beyond our team. We knew that we kind of just needed like a great Chorus API. We needed it for our team, if nothing else. We kind of knew that someday like there's going to be some need to kind of give this to a partner. There have been certain cases like when we built our native mobile apps years ago, like we did hand over the API that we did have over to this outside vendor. So we knew there's going to be things like that. We knew we needed a great API strategy and layer. And now with the SaaS business, it's like obviously even more pressing. So I'm going to do like a quick detour here and just talk a little bit about GraphQL. Like I'm assuming most of the engineers here like have either used GraphQL or are kind of familiar with what it is. Everybody else, you may not have any idea what it is. Sounds maybe like SQL, but what does that have to do with graphs? Like what is this weird GraphQL thing? So I'm just gonna spend a couple minutes talking about GraphQL, give you some examples of what GraphQL queries look like, just so you have some sense of what we're talking about when we talk about making GraphQL APIs. So GraphQL, like these are the 4 points that feel like most important to me about what GraphQL is all about. It's a way of building APIs, but it's a very like opinionated way about it. It's not even like a set of guidelines. It's like a specification, like a formal way that GraphQL APIs are built. This was written in open source by Facebook a couple years ago. And so that means that before you even like start building your GraphQL API, a ton of decisions have already been made for you, which is great. I'll stop there. It's great. It's really nice. So it's opinionated, nice formal specification. All GraphQL APIs end up working largely in this exactly the same way. GraphQL is also product-centric, which is really important. It was built with the needs of like client engineers in mind, like product engineers in mind. And so it makes it possible, for example, it's very like flexible so that no matter what kind of UI you're building, what kind of data you're showing on it, if your GraphQL API like has that data in it, you can get all that data out of it in a single API call usually, instead of, maybe making a separate API call for every kind of type of data you have within your product screen. And so it ends up being very flexible, and it's good for like practical reasons. Like if you're working in a mobile context, bandwidth is a concern, performance is a concern. GraphQL works out really well. It also it's typed. It allows you as a developer to kind of like not just like provide like pipes for getting data out of your application, but like it allows you to kind of model your domain in kind of a structured way. Like you can say, look, we have this within our GraphQL API, we have this thing called a network, and it has these certain properties. And a network may have many communities, and a community is this type of thing with these certain properties. You can sort of set up these different object types and the relationships between them, and it just allows for kind of like a shared language between teams to talk about like. We have this volume map, it has videos in it, and here's how we think about that data. Here's how the relationships between bits of data, here's what they look like, here's how those things relate to things outside of our application. As you have the shared language for talking to other teams about what's in your API, and then it also allows for kind of this flexible approach to getting stuff out of the API, which I'll show you more about here in a second. And then GraphQL APIs end up being, for lots of reasons, very explorable. Like there's this kind of tool that comes out of the box called Graphical with GraphQL APIs, where you can just like easily in a browser run a query, see what data comes back. It has auto-generated docs. It's autocomplete as you're typing your query. So just you're a developer getting dropped into a new GraphQL API. Like one, it's going to work like every other GraphQL API you've encountered, and then two, it's like very explorable. It's easy to find your way around pretty quickly. So that's some general notes on what GraphQL is. Now I'm just going to show you all a couple of or a few queries. So these are run against Tower in production, which I'll talk about more here in a second. But again, like on the left here is like, this is what a GraphQL query looks like. On the right, this is the data that comes back when you send that query off to the API. In this query here, I'm just saying, hey, I want, this API has said there's this thing called a community. It has a domain field. It has a name. I want to grab a community with domain, lookoutlanding.com. And then when I get that community object back, the fields that I want for that community are its name. And you can see here, what I get back looks exactly like what I asked for. Got a community object and a JSON, object, and it has a name field on it. It's lookout landing. And then, so once you have a basic query like this, you can kind of like start to extend it in any ways that the API supports. So like a community object, the way we set up the GraphQL API, community belongs to a network. And so, I want to grab the community and its name, which is just a string, and then I want to grab its network object. And a network object, the API is defined that a network has a name and a domain, so I want those things as well. So don't give me everything on a community, don't give me all the network fields, just give me those very specific things. That's all I want. And the data that comes back, again, looks just like the query itself. I think even like when you first start looking at GraphQL API queries, I think one way to think about it is it kind of looks like a JSON object just without any of the values, right? Like if you just put your hand over the values here on the data hash, you can kind of just see that it looks kind of like the query itself. Like the data that's returned always kind of mirrors the query. And then you can kind of just you can kind of build on from here. Okay, a community has many teams. In the case of SB Nation, where these communities are associated with specific sports teams, I can say, give me a community, give me its name, give me all of its teams, give me the league for each team. And so now we're kind of traversing the graph now, getting all kinds of data back. It doesn't really have, you never build an API endpoint to return, well, you may not necessarily build an API endpoint that returns all the set of stuff for you at once, right? You may get the community, and then you have to go get the network, and then you go get the teams. But if there's a product that needs this, they can just write a query and ask for exactly what they need. You can kind of extend it out from there, where a team has players, and players have kind of names and status. And so you're just kind of like pulling data from all over the place. And in this case, we're actually pulling under the hood, like some of this data lives in one application, some of the other data, like the teams and the players, they live over here in Hermano, our structured database. And GraphQL makes it possible to query across all those things at once. If you're a client developer, you don't need to care necessarily where that data happens to live. You just have this kind of abstract API scheme that the Tower provides that's the GraphQL API provides that allows you to pull that data back in a single query, even if that data happens to live in different applications and databases. So, that ends the GraphQL detour. There's a lot of great resources out there for learning more about GraphQL, public GraphQL APIs. You can kind of play with it if you want to kind of explore more. We also have like a product GraphQL or course GraphQL, some kind of GraphQL Slack channel set up, or if you have questions, if you're just messing with GraphQL, you can come talk to folks on ecosystem team and other folks if you're curious more about GraphQL. But what have we done with GraphQL? So here's what we've done over the last year or so. We've just made a decision that we're going to adopt GraphQL as a standard way we build APIs. We have 6 GraphQL APIs in production, or pretty close to being in production now. Volume, SBN, Hermano, all these different apps provide a GraphQL API. We have a couple of products or product features that are now powered entirely by GraphQL, the kind of assets UI and the new video management UI that the video team is working on right now. We're kind of like building out those underlying GraphQL APIs as we build out the product. And then the ecosystem team has made some libraries that make it even easier for GraphQL, for developers on our team to kind of get up and running with GraphQL. Make it easy to build APIs and to use APIs. And, I won't talk about all these, but like some of these ended up pretty cool. I think we're probably going to consider open sourcing at least this first one here. It's like a Ruby gem for building a GraphQL API. That's what we've done so far. So it's going pretty well. So that's GraphQL. That's the way that we're building APIs now. Now I want to talk a little bit about Tower. It's kind of a separate but related thing. Take a sip of coffee first. So Tower is meant to be kind of the all-encompassing API for the things that underlie Chorus. Tower is kind of what makes it possible to do the query I showed you just a second ago, to get data out of the SBN app and out of the Hermano app all in a single query. Tower's whole job is to kind of be aware of all the GraphQL APIs we built and to know the relationships between objects from different applications. Tower's the thing that knows how to say, hey, I have a community here that has some team IDs on it. I've got Hermano over here that has teams in it. Tower's the thing that knows how to tie those things together so that you can get them back in a single query. And it does that across all the sort of like cross-application relationship boundaries. So that's Tower's job. The super API, it's kind of like any GraphQL query you could send to any one of these individual APIs. You could also send to Tower, and then Tower obviously can accept the whole. You can get anything you want out of any of these APIs with Tower. So some of the benefits of this are like, if you're building a product, you're building a client app, like you don't, instead of having to know about 20 different GraphQL APIs, talk to each one individually, right, you can just go to Tower instead, and better for kind of performance and bandwidth, better for kind of like managing complexity. We can kind of put caching layers and things like that at Tower that all these underlying APIs can benefit from. So there's a lot of benefits behind this approach. And the GraphQL community is kind of known as schema stitching, is what we're doing with Tower. So what have we done with Tower so far? So Tower is up and running in production. It stitches all of our GraphQL APIs. It's providing enough. We've been working just to kind of get a critical mass of stuff in Tower such that you can actually build products with it. We had a pretty successful VAX, I think, where several VAX projects were actually just built on top of Tower, like a Box progressive web app and something else I can't recall. But like Tower's like usable now for building products. Doesn't have everything in it. You may have to add some things as you go, but there's enough there where you can kind of like get started and add to it as needed. The ecosystem team has put some really good, pretty good docs and tools in place. I say pretty good because like this stuff can always be improved. We have good documentation in the Tower wiki. We have the libraries I talked about earlier. We have some tools in place that make it easy to do schema stitching and get your API integrated to Tower. And it's starting to be used widely by folks from across the team. All these different teams are either using it or contributed to it. We're getting more and more PRs to Tower, which is a great thing. So we've got some good momentum behind Tower. I think it's working out pretty well. Pretty excited about it. So what we have next for Tower is it's kind of focusing on, as more and more things depend on Tower, we want to make sure that we just feel really great about the stability and the capacity of it. So we want to do this isn't like in response to any issues we've had. We just kind of want to be proactive and getting out in front of any future issues with some of these measures here. Right now, Tower only supports a context where a user is kind of logged in as a Chorus user. We need to take some steps to make it so you can invoke Tower from like an anonymous context. So you could use Tower from like the JavaScript layer of a Unison page, even if the user's not logged in. And now publisher partner support. Like we don't know exactly what that means yet. We don't know necessarily that we're going to like hand Tower over to the Chicago Sun-Times or anybody else. We've definitely had interest from potential customers in just generally having Chorus be more open, being more able to integrate, like, for example, like a third-party editorial planning tool with Chorus, or to be able to kind of like customize what appears on their home or article pages. And then some have actually asked, can we have an API? We just want to do whatever we want with it. We want to feel like we can get at our content that is ours. And so I think the specific plans here will become clear in the coming months, but we know that no matter what that kind of integration, customization stuff ends up looking like, having a really strong, structured, well-documented API for Chorus is going to be key to all that. So that's also what's next for Tower. Okay, one more thing. This one's pretty short. So the last thing I wanted to talk about is our development and deployment tooling. And this is kind of a little bit different than the last two I just talked about, because this work, the kind of vision and the mission, the goals behind all this work is sort of like systems team goals. And but we have Keita here, we have Jamie here. We obviously work really closely with the systems team. There's kind of an extent to which a lot of this stuff, kind of like the ownership of it is kind of shared across our team and their team. And I also just know this stuff is just like top of mind especially for the engineers here. So I just wanted to kind of give an update about this in terms of, again, like the current state of things and then what's coming up next. And there's actually a session later today, I think, where we're talking about dev blockers that Sachin is running. I'll be there, Keita will be there, and some other folks will be there. So if you want to talk more about this stuff in great detail, come to that session. It's going to give you a high level overview right now. So again, this is like, I pulled this language out of Keita's systems vision document, but the kind of goals for our development deployment tooling are, just generally like reduce the time between having an idea for something you want to build and like getting that thing live on production. Reduce all the friction and hassle between getting something built, tested into continuous integration, and then out to production, tested on a sandbox. Make all that stuff smooth as possible so you can just focus on making a great product. And then also like have tools and documentation that are good enough where developers in here, we can be kind of self-sufficient within our respective stacks. Like we're kind of managing our own continuous integration pipeline. We can kind of like tweak our Jenkins file or however we're doing continuous integration to do things the way we want to. We can feel like we're kind of like empowered to do that stuff ourselves without having to talk to SRE or talk to systems or talk to anybody else. Like ideally in our future, we want to kind of be at a place like that. So I think the current state today is that I feel like we're working toward a better world. Like we can kind of see the beautiful world that we're heading to where things are going to work great. We're still kind of just in transition right now. It's been kind of like a difficult transition, I think. Like a system with like many moving parts. We've kind of been adding or replacing like a lot of parts kind of all at once. So like using Docker for containerization, we've been making changes to how our continuous integration works. Meanwhile, like ecosystem team has been adding new applications to the mix, like Tower and Content API, which is just like more surface area where things are going to go wrong. It's just another chance for things to go wrong. More complexity if you're a developer, more things you have to understand and work with. And so when one of these things breaks, it's just not always clear which of the moving parts has failed. My sense of things is that's kind of like maybe the most frustrating thing about the current state. Like something's not working right. Like, do I have a bug in my code? Like, is this app out of date? Is that why it's not working right on my computer? Is there some sandbox bug or a Jenkins bug? It's like trying to chase down those problems is kind of like where things are frustrating today. But I think we're headed to like a really good place, and it feels like we're pretty close on some of these things. So the systems team is working on right now, they're pretty close on, is this sound check app. And this is basically kind of like a banana stand replacement, right? We built, so banana stand we built to manage our chorus sandboxes, right? So kind of a little QA environment. Spin up a sandbox, you have a little isolated instance of chorus you can use for testing and QA. And it was built in kind of like with a single service mindset, where we just had like a single web app, SBN. And we've kind of glommed on, packed into place certain things over time so you can run more services on a sandbox. But it was just never built for that thing, and it doesn't work well today. And so system team is working on an app that's kind of just built from the ground up to support a course that is made up of many different services. We're going to be at a point where you kind of push a button, deploy all the kind of course apps to a new sandbox, such that they automatically can connect to each other. You have a kind of like a well-functioning, isolated course environment. You can kind of see what branches are deployed to each, decide which branch of each service you want to deploy to the sandbox. So this is going to be this will hopefully address a lot of our kind of like sandbox-related woes. And once we have that system in place, there's an opportunity to for local development, figure out how to, if I'm just making code changes in Anthem, I shouldn't have to run all the other core services just so that I can make a simple code change in Anthem. And so the setup we want to get to is I can just run Anthem locally, and then I can point Anthem to a sandbox where all the other apps are running. I can kind of have my local Anthem participate in this instance of chorus that's running on a sandbox. So that'll be a big win for local development, where developer just has to get one service running locally. If something goes wrong, there's fewer possibilities what that thing is going wrong is, and that'll be a big win. Another part of this, again, there's kind of a theme here where we're kind of just realizing the fact that Chorus is made up of many services, and all these kind of tools have to just be natively built to support a multi-service, multi-database kind of a system. So the kind of database snapshot system we have in place today that we use for populating new sandboxes with a snapshot of production data, that currently only works for the SBN database. We're going to make it work for kind of all the Chorus data stores, so that when you launch a new sandbox like the volume database, the content API database, the SBN databases, the snapshot of production data running on those things is all in sync. So you have just a well-functioning, isolated Chorus test environment. And then just kind of continued efforts to stabilize kind of our CI/CD pipeline and improve local development with Docker. So that's kind of where we're headed on these things. As I said, if you want to dig into the details here, I recommend going to that session later today. But that's kind of where we're headed in all this. I think we're almost done here. So I just, as a final slide, I was thinking what the way to kind of wrap this up, what might the system look like in 18 months? If all the stuff we're working on comes true, right? We'll end up with a dramatically simplified SBN Rails app, which will be a really great thing for maintainability. Maybe we're in a situation where Tower and Content API are powering an Eater app, and maybe other consumer product experiments that we're able to kind of just crank out pretty quickly because we have a great API layer. Tower APIs perhaps released to licensed partners, or otherwise powering to be imagined course page customization features. You can imagine maybe we reach a point with Content API where system is easy enough to iterate on, where we feel comfortable rolling out custom story formats to certain licensed partners, or for our own brands for that matter. Didn't talk much about Unison today, but long-term vision is that the Unison product itself is also powered by Tower, which would be a great thing for just, again, kind of decoupling it from the rest of the SBN monolith, give us all kinds of possibilities later if we wanted to actually pull Unison out of SBN. And then again, solid development and deployment tools designed for a multi-service architecture that make it really fun to do development here. Hopefully some of that will come true. I think a lot of it will, and there's probably all kinds of, who knows what's going to happen in 18 months. It's really hard to see into the future, but I think this is some of where we're headed towards. That's everything. I'm not sure what our time is, but happy to guess it's 9:50. How much time do you think we have, Mandy? 10 minutes? Okay. Happy to answer any questions if you have any. I think we'll have made a lot of good progress on the content API roadmap. I don't think all the stuff I mentioned, I don't think will be done by like the end of December, but I think we've made a lot of good progress on it. I don't want to speak to where sound check or the systems team tools will be, because I don't want to throw a deadline out there, but I know we're close on that stuff, and it's being worked on. But it'll be somewhere by December, but I don't know where exactly. Yeah, for sure. Right, so that's a good question. So Tower is built on Node, which is really which makes it really easy to make kind of asynchronous API calls to do lots of things at once. And so when you make an API call to Tower, if it has to talk to 3 underlying services, it's going to do it's not going to do one and then wait for a response, and the next one, wait for a response, the next one. It's going to be like, boom, I'm sending all these at the same time, wait for them all to come back, and then send that to the client. So that addresses some aspect of the latency. You're not doing those calls serially. And then the other things we're looking at is putting Fastly, kind of a CDN in front of Tower, and putting caching systems in place so that if you're kind of making same API calls over and over again, hopefully that response will be cached at the CDN, hopefully at a point of presence close to you if you're like in a mobile app or something, and it comes right down. So those are some of the ways that we're dealing with the latency factor. Yeah, the answer is yes. Just to go back to this. Oh, I didn't put it on the graph. Good job, love it. Yeah, so imagine, if you will, an orange box. Yeah, so it's exactly right. And Content API is just one of many APIs that sits underneath Chorus. It's responsible for the stuff I mentioned, but and in Tower sits above it, just like it does the rest. Yeah, I think this chart is, yeah, I see what you're talking about. These orange boxes here really represent APIs, and so each of these apps that are underneath Tower provide an API that gets stitched up into Tower. And if you could also, so the volume map kind of does a couple of things. One, it provides an API that gets stitched into Tower, and then it also has kind of like a user interface that is used to kind of manage videos and stuff. And you could definitely think of that as kind of like a publishing and audience product. So like the user-facing aspect of Volume, it actually does use Tower so they can reach out to all these other APIs. But then the Volume app itself provides an API up to Tower that other things can use. I don't know. That's a really good question. I don't think we've made a decision on that yet. I think it's more of like a product question than kind of an architectural question, to be honest. Like we have we have like a bunch of sports data in there today, video game data, consumer product data, and if we launched another site that wanted to make use of sports data, would it use the same sports data? If we launched another video game site, would it use the same video game database that Polygon uses, or would they want to maintain their own? Like, I don't know the answer to those things. I don't think, I just don't think we know yet. I think we need to figure that out from like a strategic product perspective. Ben? I wish I had more time. I'd show you a demo because we set it up so it's pretty easy to do now. But if you've built a GraphQL API, the process is basically like, and this is all documented on the Tower Wiki, but the process is basically like you stand up your new API, you go over to Tower, you can go to the Tower homepage, and I think there's a link that says Stitch Schema. You can click it. Or I guess first you add it to, you add it to like the configuration file in Tower. You say, hey, I've got this new GraphQL API. Here's the URL for it. And then from the Tower homepage, you can say, hey, stitch the latest schema from that API. And that'll kind of bring in all the data the Tower needs to know about that API and kind of formally stitch it into itself. It used to be a few months ago, it's a more difficult process, but I think we've made it pretty easy. We've had kind of folks outside of our team just kind of stitch in their API without even talking to us, which has been pretty cool. And then I don't think I talked about this, but you can also, if you have a non-GraphQL API, like a REST API or something that you want to include into Tower, you can do that as well. It just requires more manual work to do that integration. And we integrate the Chorus asset service in that way today because it's not a GraphQL API. Joe? What's the biggest risk in architecture? Another way, what's the product or partner experience that you have after the what would you expect this? Whether it's fit into coasters, like okay, like I have no idea how this will support that. Dramatic example, but different, we're going to reinvent the how are you thinking about risk when you find like this is the right structure? I think maybe the major risk, the thing that most people tend to bring up when we look at this architecture is it sure looks like Tower ends up being kind of like a single point of failure in the mix. Like if you have everything going straight to Tower instead of calling out these services individually, then what happens if Tower goes down? So I think that is maybe the biggest risk with this architecture. I think we've obviously decided that it's a risk we can manage, and we think the benefits are worth it. And then to go back to wherever that was, and the reason we're taking up this work here around stability and capacity is to be proactive in mitigating that risk. Like we feel like if we do this stuff, we have a great kind of like staggered deployment system, a canary deployment system. We've got redundancy everywhere we need it. I've got a fastly powered caching system that can kind of absorb underlying application problems. We feel like we can kind of mitigate this risk, but I think that's probably the biggest risk of the architecture. Maybe that's everything. All right, thanks a lot, y'all. Appreciate it.
All right, before we questions